Hello everyone, welcome back to a new video. Today we'll discuss about exploiting authentication mechanisms via JWT tokens. JWTs are everywhere. Every API, every microservices, every modern web app uses them. But here's the thing, most developers implement JWT authentication wrong. And today we're going to look at one of the most critical JWT vulnerabilities, JKU header injection. Now, if you go to Portsfigure or Pentester Lab, you will find labs on this. But the problem is they're read-only. You can't see the code, you can't modify them, you don't see the actual implementation. So today, we're building our own vulnerable JWT lab from absolute scratch. We'll write the code, we'll see the flaw, exploit it by creating our own case without using purp suite, and then fix it. End-to-end, no black boxes. Now before discussing about the attack, we need to understand what JWT JKU, JWK, and JWKS is. I guess most of you already know about this, so I'll just brief a little about this before getting into technicals. A JWT is a compact, self-contained token used to securely transmit JSON data between two parties. It's commonly used for authentication and access control mechanisms. A JWT has three parts: header, payload, and signature, and these are separated by three dots. The header specifies the token type and the signing algorithm, like the SHA algorithm, RS-256 or HS-256. Then the payload contains the actual data, that is the user ID or roles or expiry time or subject, like whatever it is. And then the signature is used to verify the token's authenticity. It tells us if the token has been tampered with. Then comes JKU. JKU is a header parameter in a JWT that contains a URL pointing to a JWKS endpoint. We'll see what JWKS is. Instead of verifier already knowing where to fetch the keys, the JWT itself tells the verifier, hey, go fetch the public keys from this particular URL. It appears in JWT header like this. So basically, the JKU header is pointing to the JWKS file. Now, let's understand what JWK is. So a JWK is nothing but a JSON representation of our public and the private keys. Initially, we get our public or private keys in .pam format, just like this. We can convert these formats into JWK. So conceptually, a .jwk file and a .pam file are same. They both store cryptographic keys, but practically they're different. They use different encodings and they are also used in different ecosystems. Like JWK are used in web APIs or JWT, and PEM are used in TLS or OpenSSL or servers. There are also some differences, just that these are the same thing in different formats, which are used in different environments. So that is all about JWK, and also how this format is different from PEM. Now, JWKS, that is JSON Web Key Set. So JWKS is simply a collection of multiple JWK. It is simply a JSON object with an array of keys, and it is usually hosted at a public URL endpoint. Oftentimes in most of the target, you will find it in the well-known endpoints. So with that being said, now let's see how the flow of the authentication is and how all these four elements fits into the picture. So first of all, the application receives a JWT. We'll see in our practicals how we can create a JWT. After this, the application reads the JWT and finds the JKU URL. Then the application fetches the JWKS from that URL and the app finds the matching KID. Now what is this KID? So basically in this demonstration you can see that this is our JWKS and this is a decoded JWT. In the header of the JWT, a KID is defined. It is because in the JWKS file, there will be multiple JWK. So it will be impossible for the server to know which JWK would be used to verify the token. So that is why KID is used. Its main purpose is to uniquely identify the JWK. And after that, once the app finds the matching key using the KID, then the app verifies the JWT signature using that particular key, and then the token gets verified, leading to successful authentication of the user. So that's the normal flow, but how we as an attacker will exploit this flow is the first step. Here, the app receives a JWT, which is generated by the server itself. But in the attack, we will generate the JWT and we will also generate the JWKS. Now, let's dive into the practical. Let's build the lab. Let's do the exploit, and you will be able to understand all of it if you didn't get it till now. So stick to the video and let's go to the practical. So our goal for this lab will be to create an authentication mechanism for two user roles, a normal user and an admin, and then redirect them to different endpoints. When a normal user logs in, then the user will get redirected to a user endpoint, and when an admin user logs in, then the user will get redirected to an admin endpoint. And then as an attacker, we will create a malicious JWT and we'll try to access both these users. For building this lab, I'll be using Express, so make sure that you have npm and Express installed into your system. I won't be showing the installation process in this video. You can just refer their docs or you can just watch a video on YouTube for that. So let's start with creating an Express app first. For this, just type exp dot. It will create a basic template for the app here. Okay, it's done now. Clear the terminal. Now I'll create a search directory and store all my keys inside that particular directory. Get inside the directory first. Now I'll create a private key here using OpenSSL. Here I'll create a 3072-bit of key, that is, it's of 384 bytes. You can do different lengths like 1024 or 2048 or 4096 also. Then hit enter. And if I do ls, here you can see the private key. I'll just show it to you. Now after this, we'll have to generate a public key out of this private key. So for this, let's do ls and get public.pam. So we also have our public key now. Now we need to convert this public key from a PAM format to a JWK format. So for this, we will use a converter. There are multiple converters. You can find many online converters, but those are not recommended. There is a very high probability that your keys might get leaked. This video, I'll just use a tool. So I'll just show you the GitHub repo of it, and I'll also link it in the description. You can check it from there. This is the repo. You'll require Go for installing it. I already have it installed. So I'll just use this tool to do the conversion. Just go here, type cat public.pam, and we can use the tool JWKS. Hit enter. This is the format. Copy it here in the search directory, create a file, name it jwks.json, and just paste it, select it all, format it, done. We have our JWKS and a JWK within it. Now, since we have our keys, so let's focus on building the application now. Here you can see we already have a format. So probably if I do npm start, you can see awesome, it works. Now before starting, we'll be requiring some libraries, so I'll be installing it first. Okay, npm install -i. Okay, seems like they have some vulnerabilities in it. If you want, you can just run this command. I'll just let it be as it is for now. Clear the screen first. And now just import these libraries here. And also we'll require fs. Now, since we'll be creating an authentication mechanism, so we will need users, and I'm not really planning to integrate a DB here, then the video will get too long. So I'll just create JSON objects, and there I'll provide the username and roles and their passwords. And then we'll be using that JSON object to basically handle the mechanism. And the checks also, like the username, the role, and if their password matches and all that. Let's define the users first. This will be our users. First, user 1 is admin and user 2 is a normal user. Here I won't be requiring any APIs, so I can just remove it. So now I'll create a login endpoint in which via get request we'll provide the username and password, and then we'll check if the user and passwords are all correct. Then we'll provide the user with a JWT token. though you should not handle logins via GET requests, but still, since it is a lab I'm preparing, so for that I'm just using a GET request as it is faster and easier. We're basically fetching the username and password from the GET request, and then we're checking if the user exists in our JSON object of users, and then we're also checking if the password of that particular username is right. And then we're saying if it is not the actual users, then you just return this message, invalid credentials. And if it is not the case, then we'll start the process of token creation. Here we'll provide the endpoint where the JWKS will be hosted. And after this, we'll set the redirection path. That is, if the user role is admin, then we'll redirect the user to the admin path. And if the user role is user, then we'll redirect the user to an user path. Let's check if everything is okay. Here you can see we have our JWKS now. Now we'll have to write a middleware to check that the token that we're providing for accessing the admin or the user endpoint is actually valid. So here what we're doing is basically I'm splitting these two values and I'm just selecting this value as it is the original JWT. We'll be storing this token into this variable and then we'll process it. And apart from this, if this is not the case, if we don't get it in a format like bearer and then the token, if we just get the token directly, then we'll store the token here as it is. Because since we're using get request, so we'll just fetch it directly from the query itself. And after this, if there is no token, then we'll just return an error saying that the token is not provided. First, we'll decode the header completely. After this, we'll get the KID. So this key will be used to fetch the correct JWK, and then the token verification process will start. So for this, here we've provided the token, the public key, and the algorithm to check if the token is legit or not. Now after this, we'll just create the admin endpoint and the user endpoint. So here we've passed the verification token variable, which will be used to verify the token when we hit the admin endpoint so that any unauthenticated access is not possible. If the user and the user's role is not admin, then it will give a 403 error. And if that is not the case, then it will return a proper successful message. The user endpoint is also now done. Now let's see if everything is okay. Just save it first. Do npm start. Here. Okay, it's up and running. I go there. Awesome, it works. Now let's go to the login endpoint and provide the user credentials. Okay, here I'm getting an error saying such files. Okay, let's look at the code first. Okay, here you can see I've provided it private.key, which will be private.pem, not key. So fix it. I'll rerun it. Now let's just reload it. Okay, here it tells invalid token. Everything is correct. JWT KID. Seems like everything is good here. The JWK, you can see that we've actually not mentioned the KID. So let's mention that first. Save it. Restart the server. Again, provide the credentials. And here you can see we've got the user. Now let's check if we're also getting the admin also. Now let's check if as a user we're able to access admin, and we're getting a forbidden message. So our lab is ready. Now we can perform the exploit. So for the exploit, I'll be creating a separate set of private key, public key, and JWKS and host it via a Python server so that when we provide the JKU URL, the server is actually able to get that JWK. Now here again, I'll be creating the public key, private key, and JWKS. So let's just do it. Okay, so now the files are ready. These are our application servers keys, and these are the keys that are crafted by an attacker. Let's host the Python server here. Now I'll have to craft the malicious JWT. In the JWT encoder, you can see our existing key, and we'll also have to provide the KID into our JWK. Save it. And here, instead of this JKU, I'll say the location will be 8000 and just JWKS.json. After this, the username will be user and role will also be user. And here we'll have to provide the private key. And here I'll provide the attacker's private key. And now you can see I've got the token, and you can see our JKU is now different. Let's go back, and in the token, I'll say, and here you can see we're able to access the user. Now, if you see in our Python server, a request has been made to the jwks.json file, and this request was made by the JWKS client. Now, let's also check if we can access the admin page. Here, I'll have to modify the JWT first. Instead of user, I'll just say admin. You can also change the key ID. Like here, let's say I type attacker key, then also I'll have to change our attacker's JWK. That is, here also I'll have to say it's attacker key. And now I'll copy this token and I'll hit the admin endpoint in the token. Just type this. And here you can see, welcome to the admin area. So this is the flaw. And the main issue behind this vulnerability is not checking the source of JKU. You must check the source of JKU. So now let's see the secured way of implementing a JKU and how we can prevent this vulnerability to exist. Here, first of all, we need to whitelist the URL which should be used for JKU. The localhost 3000 and slash dot well-known JWKS.json, and if you're working on a production server, then it will be like yourdomain.com. So accordingly, you need to provide your origin, and then here, after we fetch the JKU, we need to check if the origin is correct. So for this, we can add this block. Now save it. Let's restart the server. And here, if I refresh this page, then here you can see I'm receiving an error that is the origin is not right. If I do a normal login, then here you can see we're able to successfully log in as an admin. But if we use the malicious token, then we'll be getting an error. So this fixes the vulnerability. Now, another thing we can do is instead of introducing this JKU header, we can just hardcode the URL here. Then that neutralizes the scope of creating the vulnerability completely. I'll first copy this, and if I just remove this JKU header and I'll just hard code it here. Now if I comment out this fix, and here you can see invalid token because now I am using the malicious token, and here the JKU is defined as this. Now again, if I just log in as an admin, then here you can see. So that's how you go from a working JWT implementation to a full-blown authentication bypass in just a few lines of code, and also fixing it in just a few lines of codes. So today we covered what JKU is and why it's dangerous, then how to build your own vulnerable lab from scratch, and then how we can exploit it without Burpsuit. So you can also check how you can exploit it with Burpsuit. There are a lot of videos on the YouTube, and most importantly, how to fix it with a simple whitelist. The key takeaway: never trust user input, even when it's inside a JWT header. Always validate, always whitelist. If you want to try this yourself, the complete source code is on GitHub. Link is in the description or in the blog, so you can clone it, break it, fix it. That's the best way to learn. If this video helped you, hit that like button. It really helps the channel, and subscribe if you want to catch the next one. Until next time, stay curious, stay secure, and I'll see you in the next one. Thank you.